In this example problem, I'd like to consider the following. The position of a particle is given by the function s of t is equal to t times the quantity t minus 6 and quantity squared, where t is measured in seconds and s is measured in feet. I'd like to determine both the velocity as well as the acceleration functions, and I'd like to include units on those answers. So with that in mind, first thing I'd like to do is actually do a little bit of algebra, since that can save us a little bit of calculus. So first thing I'd like to do is expand the t minus 6 quantity squared to t squared minus 12t plus 36, and then distribute the t through our set of parentheses. The reason that I'm doing this is so that we can make use of the power rule as well as constant multiples, sum and difference rules. So the velocity function is going to be given by the first derivative of the position function. So differentiating each of these terms, we will get 3t squared minus 12 times the quantity, derivative of t squared would be 2t, plus 36 times the derivative of t with respect to t, which would be 1. Putting this together, we will get 3t squared minus 24t plus 36. Now, given that the original position function was measured in feet, and given that the original t was measured in seconds, the units associated this would be feet per second. Now, unless we actually have a value of t to plug in, it's not necessary for us to do so. The acceleration function is going to be the first derivative of the velocity function, or the second derivative of the position function. So starting with the expression that we had right back here, I'm going to differentiate once more. So this will be 3 times the derivative of t squared, which is again 2t, minus 24 times the derivative of t, which will be 1, plus the derivative of 36. Because that's a constant, that will become 0. So with that in mind, the acceleration function, once we actually simplify, will be 6t minus 24. Now we started with feet per second for our velocity, then we differentiated again with respect to seconds, so that would be feet per second, also known as feet per second squared. So that's feet per second per second. Now to ask an applied problem about this velocity and this acceleration, at what times does the particle reverse directions? Now, a particle moving in a straight line will be reversing directions if its velocity changes from positive to negative. And the only way that it can change from positive to negative, or consequently from negative to positive, is if the velocity is equal to 0. So particle changes directions when the velocity v of t is equal to 0. Now, that is only potentially. We could also encounter the situation where it comes to a complete stop and then continues to move in that direction. So with that in mind, let's go ahead and set the velocity equal to 0. We'll solve for t, and then we'll verify that this thing is actually changing directions. So 3t squared minus 24t plus 36. We'll set that equal to 0. Next up, let's go ahead and factor this thing. We'll start with a common factor of 3. Take out a common factor of 3, we'll be left with t squared minus 8t plus 12. This factors pretty nicely into a t minus 2 and a t minus 6. So the velocity will be equal to 0 when t is equal to 2 seconds and when t is equal to 6 seconds. Now, if we wanted to verify that it's actually changing directions on those intervals, what we could do is point out that at 2 seconds and at 6 seconds, the velocity is going to be equal to 0. What you could do is then take a point from within each of these intervals and plug it into the velocity function to determine if the velocity is positive or negative. Now, you also might recognize that this is an upward opening parabola, and so between 2 and 6, it should be a negative velocity, and then beyond 2 and 6, it should be a positive velocity. So, certain aspect of parabolas being used here. So, the position is increasing until we hit t equals 2. Then it'll be decreasing until we hit t equals 6, and then it'll once again be increasing. So we can summarize this by saying the particle changes directions at t equals 2 seconds and t equals 6 seconds.